Consider this word problem. A transport truck weighing 9,215 kilograms is traveling down the Queen Elizabeth Way at 100 kilometers an hour. What is the truck's kinetic energy? Well, first thing we need to do is understand what the question is asking us. So let's look at this part. This truck weighs 9,215 kilograms. Well, these two terms, weight and kilograms, are somewhat contradictory. Kilograms is a unit of mass. Mass is the amount of matter or substance that an object is made of, whereas weight is a function of gravity. Weight is equal to the mass, well, there's the mass, times the acceleration due to gravity. And we're also given a speed, and its speed is 100 kilometers an hour. So let's write down here a quick list of what is given. We're given the object's mass, but I'm going to step back a little bit and let's change this into actual weight, just so we have an understanding how much this truck actually weighs. Now, weight is equal to mass times the acceleration due to gravity. We're given the mass, that is actually its mass, not its weight. And mass is 9,215 kilograms. And G we know is 9.8 meters per second squared. Doing this multiplication, the answer is 90,307. And kilogram meters per second squared is also known as a Newton. So that's its actual weight. But who understands what this is in newtons? I don't know. I don't. So let's change this to pounds. Converting that to pounds, 90,307 newtons. And we need a conversion factor. And that conversion factor comes from a table. And let's look at this table right here. And we're looking at forces, because weight is a force. And 1 newton is equal to 0.2248 pounds. So there's our equivalence. We'll use that. And as a conversion factor, multiplied by, we need newtons in the bottom for newtons to cancel out, and pounds on the top. So 1 newton was 0.2248 pounds. The newtons cancel out, effectively converting this into pounds, and that comes to 20,301 pounds. That is the truck's actual weight in terms that we understand. But let's carry on with the word problem now. In a list of given, we're given its mass is equal to 9,215 kilograms. And then we're also given its velocity or speed. And we'll write that over here is 100 kilometers per hour. And this is okay, except we need units that are in base units. We can't work with kilometers and hours. We need to change this into meters and seconds. So let's change kilometers into meters. We're going to go over here, but kilometers in the denominator and meters will go in the top. You'll follow the units and the numbers will go for the ride. 1 kilometer, 1,000 meters. 2 kilometers will cancel out, effectively changing the distance in the meters. And then we're going to change the time, hours in the seconds, hour in the numerator, and seconds in the denominator, so they cancel out. 1 hour, 3,600 seconds. So its velocity in base units is 100 times 1,000, everything divided by 3,600, and the units left over is the meter and the second. Meters per second. Let's go ahead and put this in our calculator. Here's our calculator. And it's 100 times 1,000, divide that by 3,600, and that's equal to, and I want to change that into decimals. You're going to write all of these digits down. 27.77777. It's 7 repeated. And what I got here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 5, 6, 7, 8, 9. There's 10 of them there. 1, 2, 3, 4. and the last one, and the unit, meters per second. So let's draw a little sketch of what is actually happening here. Here is the road, QEW, and here is a truck. And we'll make it an articulated truck. Now it has weight, and the weight is given us in terms of mass. Mass is equal to 9215 kilograms. Obviously the mass is pointing downwards. Weight will be pushing down mg towards the center of the Earth. That will be its weight, but we're giving its mass instead. And it has forward velocity, and that velocity is given to us at 100 kilometers per hour. And we'll call this the positive direction. We'll say the truck is moving in that direction, so we'll make that positive direction. We've already converted this into meters per second. All that's left to do now is to find the equation. And we're asked to find kinetic energy. In our equations, kinetic energy is represented by Ke is equal to 1/2 mass times the velocity squared. Let's write that down. Kinetic energy is equal to 1/2 times the mass of the item, in this case the truck, times its velocity squared. Short forming this and rearranging this a little bit, its kinetic energy is equal to mass times velocity squared divided by 2. That's what that 1/2 means. Everything is divided by 2. So we have our equation. We have everything that we need here in proper base units. All that's left to do is to take these values and put them in our equation and solve. So let's do that. I'm going to do that down here. Give me a little bit extra room to write across. Kinetic energy is equal to the mass of the item, and our truck here has a mass of 9215 kilograms, times its velocity. This is what I have for velocity. I'm going to use all of these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meters per second, and everything is squared, including the units. Everything goes inside the brackets. So we need to remove the brackets. That square operates on the number, and it also operates on the units. So it will look like this. Kinetic energy equal to 9215 kilograms times 27.77777. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squared. And the units is meters squared per second squared. Now this division of per second, I can stretch that all the way across. And divided by seconds squared. But in these two numbers now in my calculator, I already have this number in the calculator. Just a matter of squaring this one, squared, and press equals often. Now that I've squared it, multiply that times 9215 is equal to. And one thing I forgot to put in here, everything here is divided by 2. Everything's divided by 2. So take that number now and divide by 2. And that's equal to. And that's the number, our final kinetic energy value. Kinetic energy is equal to 3555169.753. And the units, kilograms, meters squared per second squared. Well, we can break this up. And these units here become kilogram. I'm going to break up the meter squared. Meters times a meter, everything divided by seconds squared. And this part right here, this is known as a Newton. Kilogram meters per second squared is a Newton times a meter. And a Newton times a meter is also has a separate name known as joule. Has the letter J, named after James Joule. All energy has the units of a joule. Now that we've done the units, let's look at this value. You want to reduce this to proper significant figures, and we go back to the original question. Here is 4 significant digits, and this one is in 3. You put a little decimal point here to represent 3. And we can't go any greater than the least number of sig figs in the original word problem. That's 3. So this gets reduced to 3. Kinetic energy. 3, 1, 2, 3. We're going to look at that last one. 3.56 times 10 to the power. I'm going to move this decimal place over. 1, 2, 3, 4, 5, 6. 10 to the power of 6. And the unit is a joule. You can take this a step further, but that's a perfectly good answer. 10 to the power of 6 is also known as mega. And it is represented by the capital letter M, so I can rewrite this. 3.56 megajoules.